Hi everyone, I am Prasad Murlidhar Timande from Bapurao Deshmukh College of Engineering Sevagram, affiliated to Rashtrasanta Tukdoji Maharaj Nagpur University RTMNU. Today in this video I am going to share my experience about my internship of embedded systems at Emertxe Information Technology Private Limited. So let's get started with the video. So it is the introduction. Nowadays, we have seen that washing machine has become an important part of our day-to-day life in order to perform daily course of washing clothes of different types. Also, it has been seen that over the course of time, with the advancement of technologies, washing machine has become capable of performing different types of functions. All this has become possible due to the advancement in the field of embedded systems. So with this project we tried to learn about working and various features of washing machines. So talking about the requirements of this project, the project is basically on the project is based on the microcontroller PIC 16F877A. The other requirements of this project are hardware requirements include LCDs, LEDs, keypad, motor, timer, and microcontroller PIC 16F877A. And the software requirements include MPLab X IDE as compiler and Pixim Lab. So let's talk about the key takeaways of this internship. During this internship, we learn about embedded C programming, which include the fundamentals of C programming such as data types, pointers, data structures, function calls and definitions. And we also learn about PIC 16F877A microprocessor, in which we learn about pins of this processor, timers and interrupts. We also study about hardware components, switching circuit, syncing circuits, LCD display, fan and buzzers. So next let we talk about the components of in brief. First is microcontroller. A microcontroller is a device which has its own memory and processor. PIC microcontroller, it is a peripheral interface controller. PIC 16F877A, it is one of the most popular microcontroller developed by Microchip Technologies. It is an 8-bit RISC microcontroller. The next component is keypad. Keypads are used to give input by the user in binary format. They consist of push buttons. They can be triggered in two different ways. First, level triggering, in which it activated when voltage is in one high level. Another is edge triggered. It is activated when level of voltage is suddenly changed. Keypads come in two different configurations. One is sourcing circuit and another is syncing circuit. In sourcing circuit, one represents on and 0 represents off, where in syncing circuit 1 represents off and 0 represents on. So next talk about CLCD. So CLCD is a dot matrix liquid crystal display. It can be configured to drive a dot matrix liquid crystal display under the control of a 4-bit or 8-bit microprocessor. So the pins available are VSS, VDD, positive supply, Now V0 contrast control, RS for register select, RE for read enable, RW for read and write, where D0 to D7 are the data lines. In this image you can clearly see the pins available. So coming on the next, uh, it is timers. Timer is nothing but a simple binary counter that can be configured to count clock pulse. Peak 16 F877A has three different independent timers which can be used as timer or counter. Now, timer 0 is 8 bit, timer 1 is 16 bit, and timer 2 is 8 bit. Basic terminology regarding timers is prescaler. Prescaler is a part of microcontroller that divides oscillator clock before it will reach the logic that increases timer status. Another terminology is FOSC, the frequency of crystal oscillator, which is 20 megahertz. So next is interrupt. An interrupt is a communication process which causes the processor to stop its current task and handle interrupting sources. There are two types of interrupts. One is external interrupt and another is internal interrupts. Important terminologies regarding interrupts are interrupt vector table. It is an data structure that associates a list of interrupts handlers with a list of interrupt requests in a table of interrupt vectors. Another terminology is interrupt service routine ISR. It is a software routine hardware invokes in response to an interrupt. So next we talk about softwares we used. Now first software we used is MPLAB X IDE. MPLAB IDE is a free integrated toolset for the development of embedded applications on microchip PIC controllers. Next software we used is PiximLab. PiximLab is a real-time emulator of development boards with integrated MPLAB debuggers. So next here is the image of hardware we have used, and the next image is of the software we have used. It is a MPLAB X IDE software. So next let's go through the project. So it is the main C file, etc. It is the installation block where initially fan is 0 and buzzer is off. It is the main block. Here written print command to press key 5 to power on the washing machine. It is the switch case for choosing the options what we have to do. And it is the block for water level program. So this block is for checking if the door is open or not. So after this we see the hardware part. This is the board, this is fan, this is buzzer, these are the keys. So let's begin to simulate our project. Now we load our hex file. Pressing key 5 to power on. Let's toggle between the options. Here are the water levels. Let's select the water level. So long pressing switch 4, select the water level. Pressing switch 5 to start, and the machine has started. Now let stop the machine. After pressing switch 6, the fan has stopped. So now the conclusion. The washing machine simulation using PiximLab is an effective tool for learning and applying concepts in the field of embedded systems. This internship offered hands-on experience for embedded systems and their programming, making it more effective to learn and laid the foundation for further exploring in the fields of automation and various day-to-day appliances. So thank you, Emertxe, for this internship.